Okay, so we are going to be finding the area under the curve. And so we will start off, we're actually going to start off with this one. Okay, so we're going to go into Desmos. So our function here is f of x is 3. Actually, let's get a new form. Okay, f of x is x cubed. So this is our graph, and so we're going to scroll in here. So our interval ranges from 0 to 1. So we're going to estimate this area below the curve. It's some sloppy drawing, I know. Okay, so first things first, we're going to go back to the problem real quick. Nope. Okay, so a lower sum of two rectangles of equal width is the first thing we're going to do. So first thing we need to realize is we need to find delta x. And so we are finding two rectangles. So again, this is our interval. And so b minus a, so b being the 1, divided by n, the number of rectangles we're going to be having. So 1 divided by 2 is 1/2. So every 0.5 of our interval, we're going to have a rectangle. And so that occurs here. Alright. And so since we're using the lower sum, not a beautiful line, I know. Okay, we're going to have to use these left-hand endpoints. So we're going to be making sure the rectangle stays below the curve because we're using the lower sum. So first thing we'll do is we will just open up this table. And so our interval, we're going to set up a function like this. So you're going to take your n value, 0.5 in this case, or sorry, your delta x value, and you're going to multiply it by the left-hand endpoints of our, so I'm going to change this to 0.5, this will be 1, we can just get rid of all this. So these are the points we're going to be looking at. So we're going to use the two left-hand endpoints first. So in this case, we get 0, and then we're going to add that on to 0.5, because that's our delta x value, and then our y value at 0.5 is 0.125. And so just looking at the rectangles, we understand this here, from our left-hand endpoint, is a height of 0 is the rectangle. So the rectangle is literally just this until 0.5. And then once we get to 0.5, this is what our rectangle looks like all the way to 1. And so we get the area of basically 0 plus this rectangle here. Alright. And so 0.5 times 0.125 is 0.0625. So we can go back to our, just gotta go back to our problem. .0625, whoops. Okay. 0.0625. Alright, Now we're going to do the exact same thing with the left-hand endpoints because it's a lower sum. Except we're going to be doing it with 4 rectangles. So we're going to use the same formula as before, b minus a over n. And so we can actually just throw in some sliders to these. Is 0, and in this case n will be 4. So we find out our delta x is this 0.25 value. So we're going to get rid of this real quick. And so now every 0.25 we need a value. So I will just 0, 0.25, 0.5, 0.75, and 1. Okay. So we can now look at this, and we're going to be making rectangles for the lower sums again. Alright. Let me get the drawing tool out. So now our intervals look like, I wonder if I can use a different color than red. Okay. Scroll on maybe a little too. Okay. So our interval looks more like this. So this rectangle is still 0 because we're using this endpoint, and the height at 0 is 0. So this rectangle really doesn't exist. And then we take the height at 0.25, and that goes all the way until here. So whatever this very small height we have here is. And then we take the height at 0.5, that carries us all the way to 0.75. And I suppose I actually have a rectangle tool here, so why don't I clear this all out and we can okay, so you can see we have all this extra space here, and that's because it's the lower sum. But anyway, now we will go back to the same point we were at before, where we're going to, I'm going to get rid of these temporarily, put in the same thing. So our delta x value, of course, is 0.25, so that's a given. And so our left-hand endpoints here were at 0, it was 0, plus, and just so you get the most exact answer here, I'm going to do 0.25, and 0.25 to the power 3. Just a little less typing. Okay, and then we're going to just add that on, and then you go to where, basically, f of x at 0.5 plus 0.25 at 0.753. And so this gives us an answer of 0.140625. 140625. Perfect. Alright, so now we're going to be doing the exact same thing, but with the upper sum. So if we remember from the first problem, now we're at delta x for when we have only 2 values. It's 0.5. So I'm going to get the rectangle tool out. And so now we measure from the second endpoint. So in this case, we start at 0, drag over to 0.5, but now we take the height at the right-hand endpoint of 0.5. And you see this rectangle has now got more of a height. And so we'll do the same thing again. We will start at 0.5, drag over to 1, and then we find it at this right-hand endpoint. And you see this time around, we have all this extra space above. And so we're basically going to be finding the rectangles here. So 1 times, I suppose, 1. Well, this is 0.5. And so this is going to be reflected in our equation. So the base of those rectangles we had was 0.5 as our delta x, and then the height of each one, so then we get 0.125 plus 0.5 times 1, and of course we get 0.5625 is the combined area of the rectangles. Is 0.5625, okay. Okay. And so this time we're going to do the same thing with 4 rectangles. We're just going to scroll it in, and I'm going to get the rectangle tool out. And so once again, we're going to find, so, oops, I've got to add these values into the table really quick. Okay. Since we're doing the right-hand endpoints of each of these rectangles, so you go from left to right, so this is the base of the rectangle. And the right-hand endpoint on the basically right side is 0.25, so we find the height there, and that's our little rectangle. Okay, now we're going to go from 0.25 to 0.5, from 0.5 to 0.75, and then we're going to get the rectangle at the height of the right-hand endpoint there again. And then once more, going towards 1. Okay. So now you see how these have all this extra space. Again, because we're doing the right-hand values. Right. So now we're finding the area of below each of these rectangles, basically, to estimate the area under the curve. So once again, we're going to get our equation. We take our delta x, in this case 0.25. But instead of using the 0 value, we go to where the rectangle is, the right-hand endpoint of the rectangle. So the height of the rectangle of our first rectangle is right there. So we'll just type in 0.25 squared. This is a little simpler. And then we get 0.25, because that's our delta x. And it's 0.125. It's a short enough one I can just write in there. Plus 0.75, our delta x. Oh, no, sorry. 0.25 is our delta x. Times 0.75 cubed. Sorry if I said squared earlier. And then once more, we're going to do it because in this case we use the f of x at 1 because we're doing the right-hand endpoints. So we get 0.25 times 1. And so our answer ends up being 0.390625. 0.309625. 390625. Okay. I flipped those around. Whoops. Okay. Alright, so now you know how to find the area under a curve like this.